Hi everyone, hope you're doing really great. Welcome back to my text type learning channel. So today's session is majorly on the conversation buffer memory. In the previous session, I have given the overview of what is LangChain memory and the overall concept of the same. And upcoming couple of sessions where I'll be talking more in depth of what is conversational buffer memory and the related types of memories. Okay. So we will be covering every key topic, including definition, parameters, use cases, behaviors, what are the migrations we can do, and with the live coding. Okay. So stay tuned till the end of the session. And if you like my channel, please go ahead and subscribe to my channel. Give it a thumbs up. If you have any specific topics, I'll surely you can put it in the comment box, and I will help you get it recorded very soon. Okay. So what is conversational buffer memory, right? It's basically simplest memory type in LangChain. It basically stores the entire conversations history with user AI format messages, okay? And it injects directly into the prompts, right? So it's a straightforward, but aware of the token limitation because it covers everything. There is no limitations of how many messages you're going to store, right? So the token limit might arise, and it anyway, since we have everything in one place, so it's a contextually good, but always take care of the token limit consideration, right? So it's basically an in-chain memory holding the entire conversations and injecting into your future prompts, right? So this is majorly useful for basic chatbots, or when you want to keep the entire session visible to your model, right? So that is where this will helpful, but not ideal for the long sessions memory size, which can go beyond the model context window, right? So that time you will have to think about different memory strategy. Okay. Now let's see what are the core capabilities or the features the conversation buffer memory offers, right? So if you see in the parameter side, we have this AI prefix, which is basically labeled for AI response in memory, like whether it's AI or system, right? AI prefix or human prefix. So for human prefix, we usually default it to human, or if it is AI prefix, it will go as a AI. You can change that. Then you will have input key and output key. Basically tells memory which input field to treat as a user input and which output field to treat as a AI response, right? That can be updated. Then return messages is basically uh, true to store or return as a structured message, else it will give it as a plain text. Okay, that are the parameters which buffer memory offers. And when it comes to the method, it gives you load memory variables. Basically it will help you to retrieve stored history for prompt formatting, right? If you want to load the entire history, you can use this. Save context is majorly for manually adding the user AI or the messages, right, to the memory. Then we have clear is basically to wipe all this stored history, okay, in a synchronous way. And apart from this, we also have async versions of all these, like a load memory variables, async version of the load, async version of saving the context, async version of memory buffer, right? So these are the async versions which we have. Apart from that, when it comes to the properties, we have buffered, like it can have the raw stored history, like it could be a string or a list, right? Or if you want as a messages, like buffer as message, history always as a message objects, right? Then we have buffer as string, history always will have a readable plain text. Okay, these are the key features and the behaviors which currently it offers. Okay, so now let's try to execute some of the examples and the key, how to use the key parameters methods for this conversation memory. Okay, so let me create one file for conversation buffer memory.py, and then I'm going to import some of the default imports. Okay, so I think we would need this buffer memory also. Let me copy paste this. So I don't need rest of the stuff. I just need this, and I may not need this for now. Okay, this is the default one. I will use it for now. I don't need embedding for now. Let's okay. Okay, so this is the basic import which I need. So now let's try a simple one where I'll just start creating the memory. Okay, memory equal to conversation buffer memory return underscore message, which I'll say it is true. Okay, messages, so it's true. Okay, now what else? I'll build a conversational chain. I think I'll have to import the chains also. Okay, so I had uncommit. I'll import this conversational chain as well. So now what I'll do here, I'll create conversation equal to conversation chain of LLM equal to LLM. Then we have memory equal to memory. Then I'll have verbose equal to true. I'll just wrap this up. Okay. Then I'll try to predict it. Conversation dot predict of input equal to hello. Okay, that is all my input is. Then I'll have to assign this. Okay, let me assign it to response one equal to this. Then I'll have response 2 equal to, I'll again do the same. I'll say here now, hello, I am tech stack learning. Okay, then I'll say in the response to what is my name. Okay, then I'll try to print both. Print response 1. I will have response 1. Response 2. I'll have response 2. Okay. So if you, this is what the simple memory that returns the objects, right? Now I want to see the whatever the stored ones, right? So let me print what are the history it has, right? History messages. I'll just put memory dot buffer as messages. Okay, this is one way. Another one is as a this is with the as a messages, and this will be as a string. So I'll have as str. Okay, let's see how the output is going to be. Then conversational buffer memory. Say I have said tech stack learning, and I have asked what is my name, and then it creates to meet you what is my name, and it has given the details, right? So here you can see the response 1 is tech stack learning, and because I have given text stack learning, it thinks that it is different. So I'll just give something called Alice. What's my name? Let's see how this is going to work. Okay. Yeah, you can see it has given your name is Alice, right? And the history messages, it gives you in the message format, right? It's messaged object format, whereas as a string, it gives you just the string format with the human AI format, right? Okay, so this is about the first thing, like where we saw the written messages objects, how it is giving, how the predicts are happening, automatically saving the input and output, how does it can fetch up back the buffer as a message and the buffer as a string, right? Now if you we have seen coming back as a string and the object, right? Now let's see how do you inspect memory buffer, right? So you saw as a buffer of messages and the string, right? Now let's see in another way, just putting the inspect. Okay, inspect memory raw list, right? So here you can see print, you can say raw buffer. Okay, then here it should say memory dot buffer. Okay, this is one part of it, and you saw as a string, you have seen already how does it look, which is basically giving in a AI human thing, right? Another one I want to show how does it look is about the inspect via load memory variables, okay, for prompt injections. So here I'll say print, then memory variables for prompts, then I will just put memory dot load memory variables. Okay, this is one way, and another concept here we have is manually save context, right? So if you have any something in between you want to store it to the memory, then you can put save context, then I'll put input colon I live in NY. Okay, and then I'll say output will be got it, you live in NY, right? Then after manual save, let's print it as a buffer. Okay, print after manual save, we will store memory dot buffer as string. Okay, now after displaying, if you want to clear memory, this is another concept we have, clear memory. So here what you will do, memory dot clear, I'll call, and I'll print after clear, I'll try to print as a string, and you will see it may not have anything, it will be empty, right? Let's run this and see. Okay, I'm Alice, then it says context, save context, where is it? This is my mistake. Okay, so it has said hello, I'm Alice, and and it has given how are you today, and it has given your name is Alice, and it has printed the strings and messages. And now raw buffer, this is how the raw buffer looks like. Okay, buffer. Then you will have memory variables, right? Load how once you load the things, how it looks like. This will be the structured ones, right? You will have history, right? You will have AI message, and rest of the things are different, right? And after manual save, you see the entire conversation has been appended it back again with two other uh, context, right? And then after clear, nothing is there. Okay, these are the common basic things which you will have to be aware of. Okay, now let me comment all of this, and I will just show you on the async ones. Okay, so let me create. We have buffer memory, then we need async queue, then I'll create async def async memory demo. Okay, then I'll say mem is equal to conversation buffer memory of return message equal to false, which I don't want return message for now. Then I'll say await mem dot is save, one sec, is save underscore context of, I think I can just copy paste this. Okay, so I have I'll say instead of this I'll put hi, hello. Okay, that's all. um, then I'll say um, what's equal to await mem dot load memory variables. Okay, then let's print and see. Print loaded what's, then we will have print async buffer await mem dot clear of this, which I'm going to clear it. Then await, I'll try to print it mem dot a buffer as string. Okay, and then I'll run this function async queue dot run of async. Okay, this basically shows how you can async way add the context, how to load the context and variables and clear the things, right? So you can see it has loaded, it has nothing is there because it is done, it is cleared, right? Okay, now assume if you want to put some custom keys like input key and output key, right? So I will just comment this out for now, and let's start freshly. Custom keys. Okay, so we will have memory custom, then I'll say conversational buffer memory of, then I'll put memory key. This is my custom key, which I'll be giving it as chat history is my memory key. Then I'll say input key equal to I'll say user input then output key equal to, then I'll say agent response. Okay, then I will say return messages equal to true. Okay, next file I will also need the prompt template here, so let me import that. um, Prompt template, then I will create one. Okay, prompt template dot from template, then I'll have this is a history. Is it? Yes, so history colon slash n. I'll just put chat hist, right? And then I'll say user input is going to be user input. Okay, and then I'll say AI, that is the AI response. Okay, and this is what my prompt template looks like. And now I will say from LangChain, I might need LLM chain dot chains import LLM chain. Okay, then chain custom equal to LLM chain of LLM equal to LLM, then prompt equal to prompt, then we have memory equal to custom memory custom, then I'll say output key equal to agent response, then I'll say verbose equal to true. Okay, so then I will just print and we'll see how the response comes in. Okay, chain custom dot invoke of user input hello. Okay, and then I will put an I'll put who am I. Okay, let's run and see. From template, yes sir, from template. Hello, I'm Alice, and then I'm asking who I am, and it responded as you are Alice, right? This is the custom way of adding the input and output keys. Okay, and assume if you want to add user messages, add user message or add AI messages, right? Then you can use this way. Let me just have that particular example handy. I just paste it here. So here you can see you can put the same one and then chat memory dot a add user message and add AI message, and then you can load that and see how is it getting added, right? So these are the several examples which you can use it within your conversation buffer memory. Okay, so why to use conversation buffer memory? What are the pros and what are the limitations it offers, right? So it enables the context awareness, right? Multi-turn dialogue, and it is very simple to set up and plug and play, right? And no additional setup required for basic use cases. So it's basically great foundation for learning conversational AI workflow. So for that, you can use it. But what are the limitations it offers? It has a conversation history, as and when the conversation history grows, right, endlessly, can exceed up to the like LLM's token limit, leading to the dropped content, like trunked content, right? So no summarizations or memory compression. So it doesn't have any offering for this. Then we will end up with the token limits, and then we will have, so this recently this will get depreciated, so you'll have to use the runnable with message history or LangGraph memory, right? So this is the pros and cons for using the conversation member for memory. So that's the end of our session related to conversation buffer memory. So we have learned that conversation buffer memory stores entire conversation context for multi-turn LLM integrations. Then it's ideally only for simple chatbot. You can use written message and certain parameters to handle the objects. And always you need to be aware of token growth in long sessions, right? So you'll have to take care of that. So that's it about today's sessions. And if you like my channel, please go ahead and subscribe to my channel and give it a thumbs up. If you have any specific topic, please put it in the comment box. I will try to get it to you as soon as possible. Thank you all.